everyone. So there are a few more ways that we can go about transforming our data to make it work for us, to make it answer some questions for us. I have our studio open here and I have the customer's data set loaded. So I suggest you go ahead and do the same so you can follow along. Data transformation is the data conversion process from one format or structure to another. It's as simple as that. We do it to meet the requirements of statistical and data mining techniques used for an analysis. And the analysis that we need is going to vary based on the problems that we're trying to solve. Sometimes it makes sense to group a broad range of numerical values into a small number of bins, for example. Binning transforms numerical variables into categorical variables by grouping the numerical values into a small number of groups, or, as they're often called, bins. Bins are consecutive and non-overlapping. It's important to note that each numerical value must only fall into one bin. If a value falls into multiple bins, it will be double counted and it will have a negative effect on the quality of your analysis. Binning can be really useful because it can reduce noise and variance in the data if we believe all observations within the same bin are going to behave the same way or similarly. Binning also helps categorize observations and meets categorical data requirements of some analytical techniques that we'll get into later on, and maybe some analytical techniques that you'll discover in your careers as business analytics professionals. There are two primary approaches to creating bins. The first is equal intervals, where each interval is of the same length. Or you can have equal counts, where each bin has the exact same number of observations. So to better understand our customers, we want to perform what's called an RFM analysis, or a recency, frequency, and monetary analysis. And we can create RFM ratings using variables in our customers' data sets, like the days since last for recency, num of order for frequency, and spending 2018 for our monetary variables. So following the 80-20 rule, that 80% of business comes from 20% of your customers, for each of the three variables, we want to bin customers into 5 equal-sized groups. So pause for a second and think about, why would we prefer this to bins with intervals of equal size? Each group will be assigned a score from 1 to 5, with 5 being the highest. And customers with RFM ratings of 5, 5, 5, or greater are probably going to be considered by the company to be the most valuable. So to create the recency score, we want to transform the days since last variable to reverse the order of the data, because the more recent the order, the higher the score. So let's go ahead and create that recency score. So first, we are going to create a new variable called days since last reverse, because we want to have the inverse of the days since last variable to create this recency score. So to do that, we're going to pull from our customers data set, and we're going to create a variable in this data set called days since last reverse. We're going to use the assignment arrow, And now we want to create a numeric variable, so we use the as numeric function, and we want to use the days since last variable, and we want to multiply it by -1. So we want to basically flip the order in which the days since last variable occurs to get a better sense of who's placing orders most recently, as opposed to getting a count of how long it's been since somebody has placed an order. We want to know how recently they've placed that order. So if we scroll over in our customer's view here, we can see days since last reverse is now a variable that we have created. So now to create bins for this days since last reverse value, we are going to create a new object. We're going to call it Recency Bins. And remember, everything in R&R Studio is case sensitive. Quantile is the function we're going to use. And again, this will help us make sure there's an equal number of observations in each one of our bins. And then we're going to use the days since last reverse variable. And then we're going to use a little bit of code to have it properly divide our observations into 5 equal-sized intervals. So that by .20 in the sequence of 0 to 1 basically means that 20% of observations are going to be in each one of the bins. So now we see under values that we have our recency bins created. Then we can create the other bins. And these are a little bit more straightforward because the core variables that we're using don't require a transformation like the days since last variable required. So to create frequency bins, we again use the quantile function. Customers, we're going to use the number of orders variable this time. And then again, use that little bit of code to have it divide the observations evenly so that there's the same number of observations in each one of our bins. And again, we see under our environment tab that frequency bins has been created, and then we can do the same thing with monetary bins. And here you can see that I made a typo in this code. Between by and 0.2, I did not include an equal sign, so it gave me an error. And again, it's fine to have errors in your code. You just want to go back and carefully check your code to look for a mistake. More often than not, it's going to be a typo or a spelling error. And you'll be right on your way, just like that. And now in the environment pane, we have the frequency, monetary, and recency bins. So we can use the cut function to assign elements into the different bins. So let's take a look at what that might look like with the recency variable. Or rather, we're creating the recency variable in the customer's data set by dividing our observations into the recency bins that we created. Then we're using our breaks to tell it where the different items are going to be divided into. We're going to use our recency bins. And then we are going to label each of these items as a value of 1, 2, 3, 4, or 5 to help us create that RFM score. And then we're going to throw in a little more code to make sure that we are consistently formatting our variable. So we're going to use include lowest, true, and right, false. And for more specific information on what every single element of this code means, the textbook has a lot of very clear and specific definitions of every single element of the code. So now if we go all the way over to the end of our customer's data, we see that we now have this recency variable, and that is awesome and helpful and one part of our RFM score. So now we want to go ahead and do that for our frequency and our monetary items. And to make that a little bit easier on us, if we're live in the console, we can hit the up button and we get the previous code that we used. So we can change recency to frequency. And we want to change days since last reverse to num of orders. And our breaks are going to be our frequency bins. And the rest is going to be the same. So we can hit enter. And now we have also created that frequency bin as well. So we can take the same approach for monetary. Change out frequency for monetary. Change num of orders to spending 2018. That was a black cat named Marvin who made all that noise. My apologies. That could be good bait for an extra credit question, just to see who's sticking around to about minute 15 in one of these videos. I know it can sometimes be intense and time consuming to walk through how to set up a lot of this code. And instead of frequency bins, we want to use our monetary bins. And now we should have all three of our recency, frequency, and monetary categories. So those are our RFM scores. So each observation is classified into bins for each element of an RFM analysis. And that classification is in the data set. So to create the RFM score, we want to combine the three RFM indices with the paste function. So instead of having this organized into three separate columns, let's smoosh it into one using the paste function. So we're going to create this new variable, RFM. We're going to use the paste function, if I can type correctly. There we go, there's paste. We're going to use the recency variable, the frequency variable, and the monetary variable. And let's see what that does for us. And now we have this variable, RFM, and instead of these items being in three different columns, they're all in one. And this is handy because if we were to sort our data based on recency or frequency or monetary, we may lose this ordering. So by using the paste function and pulling all of these values together, we have a consistent score that we can look at. So if you're following along in R&R Studio, make sure that that very first RFM score is 411. Now, we might, in addition to the RFM binning, we might want to bin the income variable into 5 equal intervals as well. So here we can create a variable called binned income. And again, we can use the cut function. We're going to use the income variable as our base. So we have income, and then we want to have it broken up into 5 bins. And we're also going to label each item a value of 1 to 5. And again, we're going to use that little bit of code to make sure that we're including all of our values and formatting things consistently. So we're going to use include lowest, true, and right, false. So now we might be asking, what are the ranges of the values in each of these bins? Although we can scroll over here and see that we have our different values in our binned incomes, but we can use the levels and the cut functions together to figure out the different ranges of the values in these bins. So we're going to use levels, cut, customers, and income. We're interested in that income variable. breaks equal to 5. So here we can see the range of values in each of these bins. Of course, it's expressed in scientific notation, so that's fun. An extra challenge, there are commands you can use to tell R not to produce values in scientific notation, and they do appear at a few points throughout the text and even within this chapter. So I challenge you to find that, because I think that type of output might be a little more intuitive to work with. And we can use the table function to see how many observations fall into each category. So table, customers, and then we're going to look at binned income. And that gives us a little tiny text table showing us that in the first bin we have 67 observations, in the second we have 72 observations, and so on. So in our RFM analysis, each bin had the exact same number of observations in it, but our income bins do not have the same number of observations in them. And well, that's what we wanted. We can also define our own bins. We're not just stuck creating bins of equal size or equal interval. We're creative business analytics professionals, and we can do what we want. So we can create user-defined bins using the cut function, using the breaks option. So say you wanted to create a tiered membership status where different services and rewards are offered to customers depending on how much they spent in 2018. We want to assign bronze membership status to customers who spent less than $250, silver membership status to those who spent $250 or more, but less than $1,000, and gold status to those who spent more than $1,000. So, how can we do this? Well, let's get started. So we're going to create a new variable, and we're going to call it membership tier. So we're going to type in customers membership tier. We're going to use our assignment arrow, and now we're going to define what we want to be defined in membership tier. So we're going to use the cut function, and we're going to look at the spending 2018 variable. And we're going to define our own breaks. Zero to 250, 1,000, and INF, which means infinity. And then we want each of these breaks or these categories to be associated with a specific label, so we can use the labels function. So our lowest tier, we're going to call it bronze. Our next tier is going to be silver. And our last tier is going to be gold. So now we can scroll over in our data set, and we can see the membership tiers that everybody is associated with. So we can see that our very first observation is in the bronze tier, for example. How might we go about figuring out how many people are in each tier? Well, we could try the table function. And using the table function, we see that we have 35 bronze tier, 118 silver tier, and 47 gold tier members. And take a second and think about the size of this data set and if you think that's a pretty good distribution of customers in each one of these membership tiers. Because remember, this isn't just coding, this isn't just statistics, this is real business decisions.